In part two of the lesson today, we're going to graph one more quadratic, and then also we've got a couple word problems. So we get to actually see why do we end up dealing with these quadratics. So that's what we're going to learn today. So let's go ahead and solve for y. That's the first thing you always want to do is get y by itself. So move these terms over. So when I do that, whenever you move a term from one side of the equal sign to the other, the signs just end up switching because you end up having to subtract that 3x squared. I'm going to write down that plus 12x next, and then the minus 8 because I had to subtract it from both sides. So remember, the first thing I need to do is find that axis of symmetry, which goes negative b over 2a. So I go ahead and substitute those numbers in there. And when I do that, I end up with a negative 12 over, and then 2 times by negative 3, which ends up giving me negative 12 over negative 6, which is just 2. So 2 is the axis of symmetry. So along this blue line here, there is going to be a graph, and it's going to end up being a parabola, a U-shaped graph. It'll end up opening down because it's a negative x squared term. And if I cut right alongside that blue line, it'll cut this parabola into two equal pieces. So the next thing to do is find the vertex, the y component of the vertex. This is the x component of the vertex. And so I just take that 2 and put it in for these x's. So it's negative 3 times by, and then I've got the 2 squared, and then plus 12 times by 2. And then a minus 8. And so I do some work there. 2 squared is 4. 4 times negative 3 makes negative 12. Plus 24. Now remember what I've said. I've said this a few times. When you're solving for this vertex, the first and the second terms, you know you're doing something right if these are opposite in sign and one's double the other. So that helps you out trying to figure out what the subtraction is, especially if it's a big number. So that makes 12 minus 8 gives me 4. So I know that the vertex is at 2, 4. So that's where I'm going to start. I'm going to go over 2 and then up 4 spaces. And then from there, I kind of have a general idea about what it looks like. It's going to end up opening down. Well, I'm going to use this parent graph again, but if you don't remember the parent graph, and a lot of the kids forget it, how it works, or don't really understand it, well, then just go to what the y-intercept is. If you cross out the x values, set those equal to 0, the y-intercept is negative 8. So if you just go down 8 spaces on the y-axis, put a point there, and opposite of that y-axis, or for this axis of symmetry, you see it's 2 spaces to the axis of symmetry, opposite of it, 2 spaces, it's going to be another point. And that just gives you a general idea about what it looks like. So pretty much you could just go ahead and draw the graph. But if you want to be a little more precise to get full credit on a test, you got to give me the next 2 points that are somewhere in here. So let's figure out where. All you have to do is look at the parent graph, just this portion of it. This y equals, and then it's the negative 3x squared. If you plug in a 1, a positive 1 or a negative 1, and square it, you always get 1. 1 times by negative 3, that gives me negative 3. So what I'm going to end up doing is from the vertex, if you go over 1 to the right or 1 to the left, you're going to end up going down 3. Why down 3, they ask? Well, it's because that's what it says right here. The y value says minus 3. That means down 3. Why did we go 1 to the right, 1 to the left? Well, that's what I plugged in for x right here. I plugged in a plus 1 or a minus 1. And this is just the parent graph. So the parent graph always treats the vertex as like the origin. So that's where you start. And so if I go over 1 or to the right, over 1 to the left, that'll give me my points. Over 2 or plus or minus 2 gives me 4. 4 times negative 3 gives me negative 12. And you'll see how you get that point. See, if you go over 2, if we go down 12 spaces, we'd be at those 2 points we had before. And so there it is, the general shape of this graph. So it's a parabola. All y equal negative 3x squareds will look the same. So you could end up drawing that a little better than I did. I kind of squiggled the line a little bit, but they are symmetrical about that blue line that I drew initially. So there it is. Well, here are a couple word problems. And so let's take a look at the first one. It says the height in feet of an acrobat who jumps from a trampoline 10 feet in the air to a large mat on the ground can be modeled by this function. So here it is. Here's a quadratic. So the person free falling, from the trampoline they jump up and then they come back down. So we kind of have an idea about what it looks like. It kind of looks like this. But it's not both parts of this graph. It's only one part. See, they start 10 feet up. That's the y-intercept. And so you're going to go up 10 feet right there, and that's where we're going to end up starting. So whatever this value is, whatever the c term is the starting value. So c equals the starting value. And where did I get c from? Starting point, I'll say. Well, where I got c from is it's ax squared plus bx plus c. So c is the constant. It's the y-intercept. And so x is the time in seconds. Find the maximum height for the acrobat and the time it takes to reach the height. And then also we're going to find out how long the acrobat was in the air for. Well, actually, they have maximum height first, but we can't find that first. We need to find the time first. Time is the axis of symmetry formula. This part right here is just going to be the negative b over 2a. That's all it is. It's just the axis of symmetry. That's going to be the time to the maximum height. So let's do it. Negative b, so x equals negative b. Actually, I'll go x equals t's for the time, equals negative b, which is negative 16 over 2 times by negative 8. Well, that makes negative 16 over negative 16, which makes 1. So there it is. It's only going to take 1 second to reach that maximum height. So we know that that vertex is going to be somewhere along this line, this imaginary axis of symmetry line that I'll sketch in here. So that gives us an idea about how to graph it. That means the point's opposite this. So this point here is one space over, so that means I must have a point right there. Just need to figure out how far up I need to go. Well, let's go to the next value, the y value. The y represents the height, the maximum height that I'm going to find. So h is the height, y is the value that I typically call this axis, the vertical axis, and we substitute 1 in for these x's. So negative 8 times by 1 squared, and then plus 16 times by 1 plus 10. And so 1 squared makes 1. 1 times negative 8 makes negative 8. Remember what I said, the first two terms should be opposite in sign, one double the other. And then from there, you do some work, makes 8 plus 10 makes 18. So there it is. 18 feet is the maximum height. So if I go from 1 second over, I go up 18, there's the point right there. So now we got an understanding about what the graph looks like. It's going to come up, and then it's going to end up coming back down. And so it's going to hit that point right there and then come back down. We just don't know how far it's going to end up coming down. And so let's take a look at what we can do to come up with the last part, the time in air. Well, the time in air, notice that eventually it's going to end up hitting this x-axis here, and that would be at height 0. So the time in air means that the height equals 0. So what we want to do for this is put 0 in place of the y value and then just solve for x. Well, we're not quite sure how to do that yet. So what we need to do is we just need to carry this out. We know if we go over 1, we're going to end up going down 8 spaces. Let's just do the next one. Let's use that parent graph again. Eventually, we're going to learn a way to find these x-intercepts, or these zeros that we have talked about before. But right now, what we're going to do is we're just going to use the parent graph. So if I use this y equals, or let's go height equals, or f of x equals, negative 8x squared. We already know 1 brings us down 8 spaces. So let's go ahead and plug in 2. Let's put in 2 and then square it and see what we get. That makes 4. 4 times by negative 8 makes, well, negative 32. So that brings us way down here for 3. So it's going to be somewhere way down here. So there's 18. And negative 32, actually, that'd be even further down here. So it's somewhere way down here. So what we can do is just kind of sketch in what we think it's going to end up looking like. And then just head towards that point. Well, once it hits here, it's actually hit the ground. It's not going to go any further, but it would continue out. Well, what point do you think that is? It looks like it's right in between these two values. So we'd say the height 0, well, the time in the air, well, it took about 2.5 seconds. Is what I would say. And it's just approximation. That's all we're doing in this lesson. It's just approximating that value. Well, let's take a look at the next one. Here it says the height in feet of a soccer ball that is kicked can be modeled by the function. Now notice there's no there's no c term. There's no value in which we just have a constant. That means the soccer ball started on the ground. Since we see no c term, that means that it started on the ground. And so that's something that you should always look for, where it starts. So we know it starts right here on the ground. That's the height in feet there. And so we're trying to find the same sort of thing. We're trying to find the maximum height, but we can't find that first. We first need to find the time to reach the maximum height. So that's negative b over 2a. So let's go ahead and substitute some numbers in there. So our b value is 24. So it's the opposite of 24 over 2 times a. Let's go look at see what a is. Negative 8. And we go ahead and do some work there. Negative 24 over negative 8 times 2 makes negative 16. Now we've got ourselves a fraction. It makes the problem a little bit tougher here. So we go ahead and reduce that, take out an 8. That makes negative or positive 3 halves. We'll say 1.5 seconds. So there it is. 1.5 seconds. 1.5 seconds to time to reach the maximum height. Use this fraction. Don't use 1.5. It's a whole lot easier. I'll show you how. So we want to find out what the height is. So height equals the same thing as this f of x. It means the same thing. That's just a function notation, they call that. So negative 8 times by 3 halves squared plus 24 times by 3 halves. People get afraid of fractions, but actually they're kind of your friends here because they end up making the problem a little bit easier. You'll see why in just a minute. Square both of these numbers. That makes 9/4. And then times by negative 8. Notice that the fraction is going to reduce here. Over here we could do some reducing to start with, so let's go ahead and do that. The 2 goes into 24 12 times. 12 times by 3 makes plus 36. Over here 4 goes into the negative 8. We have a negative 2 times. You multiply these two numbers and we get ourselves negative 18. And remember, as I said before, you know you're doing something right if the first term here and the second term are opposite signs and one double the other. Ignore the negative sign when I talk about double. Well, when we subtract, we're going to end up with 18. So there it is, 18 feet. Hey, isn't that the same as the last problem? 18 feet. So it's the same for both in this case. Well, from there, what we can do is we can find the time in the air. So we know it goes up 18. So let's count 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right there. Okay, so over 1.5. So there's 1.5. So there it is. This is 18 right there, and this was 1 second, 2 seconds, 3 seconds, 4 seconds. So we know that point. We know it starts here. Well, that means that this right here we found 1.5 is the axis of symmetry. So we don't have to do any extra work to find out this time in the air. All you have to do is use symmetry. Take a look at this. You see how your 1.5 spaces over to that axis of symmetry? That means there's another point 1.5 spaces over. So there it is. 3 seconds. We found our time in the air. 3 seconds. That was a little bit quicker than the last problem. Well, those are some problems that you'll end up seeing on tonight's homework. Good luck.